Okay, today we're looking at dimensional analysis as a mathematical problem-solving technique. So, dimensional analysis is a technique, and a lot of times students kind of resist this. So I want to go through an analogy first before we get started. So let's say you're in art class, and your art teacher gives you some charcoal and says, okay, everybody, I want you to make a charcoal drawing of a cat. And you draw a marvelous charcoal cat. It's wonderful. Everybody can tell it's a cat. And you get an A, okay? Now, the art teacher now hands out watercolors and she says, okay, I want everybody to make a watercolor of a cat. Well, you made a marvelous charcoal drawing and everybody can tell it's a cat, so you just turn in the charcoal drawing again. And for some reason, your art teacher is not pleased. And the reason is you were asked to master the technique of watercolor, not repeat using charcoal drawing. So what we're doing today is we are mastering the technique of using dimensional analysis. I know there are other ways of solving the problem. This technique is used for many of the math problems in chemistry and physics. It uses conversion factors to convert from one measurement to another. For example, an example of conversion factors is that 10 millimeters is the same thing as 1 centimeter. So before we begin, let's do a little math refresher course. Coefficients, that means the numbers in front. Numerator is the number on top. Denominator is the number on the bottom. So let's solve a problem using dimensional analysis. As in part of the problem solving, you have to show all your units to receive credit for in-class work. So let's start with an easy problem. A college student has 110 nickels but wants quarters for laundry. How many quarters will the student get? Now we happen to know that 1 quarter is the same thing as 5 nickels. We're going to start by saying, okay, I've got 110 nickels and I need to find quarters. And we're going to write out the conversion factors looking like a fraction. So we know that 1 quarter is the same thing as 5 nickels. Or we can say that 5 nickels is the same thing as 1 quarter. So we're going to solve our problem starting with 110 nickels. So we start with 110 nickels. And we want to multiply this by either the conversion factor with the x by it or the conversion factor with the y by it. So we want to cancel out. So we're going to cancel it out, and we're going to use railroad tracks to represent that we're multiplying things, actually because it's easier to draw. We're going to say 5 nickels and 1 quarter. So we multiply 110 by 1, and we get 110 over 5. And our nickels have canceled out. So we have 110 divided by 5 quarters, and that is 22 quarters. And there's your answer. Okay, so what we've done here is we've used the units in order to cancel things out. We've turned our known into conversion factors. Let's do another one. Oh, why would you want to use dimensional analysis? Okay, so let me give you an example of why we're going to use this. This is an example of a stoichiometry problem where you're given some sort of question. And the typical way that we solve these is unit cancellation, where you see where we just keep canceling these things out. Now, when we do these, just to make it easier to write out, we are going to be using what I will call railroad tracks, okay? And it just makes it a little easier if you're putting this into a PowerPoint or doing it by hand, a little less writing for you. Okay, let's do another problem. How many teaspoons are in 3.2 cups of cough syrup? So our given is 3.2 cups. We want to find teaspoons, and the abbreviation for that is little t, so little t, little s, little p. And if you cook, you know these conversion factors, that 1 cup is the same as 16 tablespoons, and 1 tablespoon equals 3 teaspoons. So we're going to start off with our given, which is 3.2 cups. Unit cancellation says that we're going to bring the units down. So we're going to bring cups down. And we're going to go to tablespoons, TBS. 1 cup is the same thing as 16 tablespoons. So we have canceled out our cups. Next, we need to cancel out our tablespoons, TBS. And we look and we go, oh, I can go from tablespoons to teaspoons. So we're going to put TSP in the numerator. And we have 3 teaspoons for every 1 tablespoon. So we multiply everything on the top and divide through by everything on the bottom, and you get 153.6 TSP. Now, the last thing we're going to do is correct for sig figs. There's 2 significant figures here. So we're going to round to 2 significant figures. So your final answer would be 150 TSP for teaspoons. Okay? Now remember, you can rewrite these using the railroad track system, and I'll try to do that on the next one just to show you what that should look like. Okay, the last one. My rich uncle dies, leaves me a 22-meter long yacht. How long is the yacht in feet? I need to know that because I need to get a boat slip for it or whatever it is you do for yachts, okay? So my given is 22 meters, and I want to find feet. And I'm given all these conversion factors here. Now, what I want you to do is go ahead and pause the video and try to work these out by yourself. I have the answer up here before we do sig figs. So go ahead and pause the video. All right, I will work it for you. Let's see how you did. We have 22 meters. We're going to bring meters down, and we're going to go to centimeters. So 1 meter is the same thing as 100 centimeters. So I've crossed out my meters. Now I'm going to cancel out my centimeters, and I'm going to go to inches, and 1 inch holds 2.54 centimeters. So I've crossed out my centimeters. Now I'm going to bring my inches down, and I'm going to go to feet, and we know that 1 foot holds 12 inches. And you put in all the numbers, and you're going to end up with this answer right here. Now, let's correct for significant figures. 22 has 2 sig figs, so my final answer will be 170 feet. I have one last problem for you. So we have 500 ml. And notice I put the decimal point there. And we are going to try to find pounds, and the abbreviation for that is LB, okay? So we're going to start with 500 mLs. We're going to bring mLs down. 1 ml of mercury has a mass of 13.6 grams. We're going to bring grams down, and we're going to go to pound, and 1 pound is 454 grams. And if we do the math on this, this is equal to 14.97 yada yada yada. We should have 3 significant figures, so it's going to round to 15.0 pounds. All right, that is your final example.